Welcome to the Cosmic Complex Q series from XFO Intelligence. Yeah, this is where we apply the deep augmented thinking method to answer some of the most challenging questions of our time. Today's question is one that has fueled our collective imagination for generations. You know the one. Can we terraform Mars or other planets for human habitation? For decades, the dream has been so vivid, right? Science fiction visions of crimson deserts blooming with forests, of blue skies replacing the pinkish haze. All of this has shaped our ambition to become a multiplanetary species. Yet, after decades of robotic exploration and an increasingly sophisticated analysis, a really sobering reality has emerged. Terraforming Mars, creating a planet-wide Earth-like environment it's fundamentally impossible with any technology we can conceive of this century. Now, this isn't a failure of engineering ingenuity. No, it's a consequence of immutable physics. But, and this is important, this realization doesn't doom humanity's Martian future. Actually, in fact, it liberates us to pursue a far more achievable and resilient path. So, let's break down the physics of impossibility. Okay, there are three insurmountable barriers. First, you have the mass deficit problem. To create an atmosphere thick enough for humans to breathe without pressure suits, Mars would need, get this, approximately 100 times its current atmospheric mass. So where would this come from? Well, comprehensive studies reveal that even if we vaporized every single trace of frozen carbon dioxide at the poles and unlocked every molecule from the soil, we would gather less than 5% of the required mass. Wow, Mars simply doesn't contain enough accessible ingredients, and importing this mass from comets? That would require an energy expenditure exceeding humanity's total output for millennia. It's just not feasible. Second, there's the gravity constraint. See, Mars possesses only 38% of Earth's gravity, and this results in an escape velocity that's just too low to retain a thick atmosphere over geologic timescales. So even if we could magically create an Earth-like atmosphere tomorrow, solar wind and thermal escape would erode it to uninhabitable levels within 10 to 100 million years. That's a catastrophic blink of an eye for a civilization. Right. Gravity is a fixed planetary property. We just cannot alter it. And third, the radiation reality. Okay, so without a global magnetic field and with its thin atmosphere, Mars's surface receives radiation doses 50 to 100 times higher than Earth's. And to reduce this to safe levels through atmospheric thickening alone, well, that would require an atmosphere Mars doesn't have. Physics offers no shortcuts here. Radiation shielding requires mass. It's an equation that is just unforgiving. These constraints, they aren't temporary obstacles just awaiting a breakthrough. No, they are fundamental boundaries. Acknowledging them isn't pessimism. It's really the necessary first step toward a realistic plan. So, what is the new plan? The critical insight emerging from our analysis is this. Human survival on Mars doesn't require transforming the entire planet. No, it requires creating interconnected pockets of habitability that work with the Martian constraints, not against them. Nature itself provides the blueprint for this. Think about it. Earth's biosphere isn't a uniform blanket. It's a network of life-supporting niches, oases and deserts, hydrothermal vents in abyssal plains. So Mars settlement should follow this exact same principle. Not a single planetary atmosphere, but a distributed network of shielded habitats. And this approach, it reveals some surprising advantages. For one, radiation protection becomes simpler. Yeah, just 3 meters of Martian regolith provide shielding equivalent to Earth's entire atmosphere. Wow! And subsurface habitats within natural lava tubes, of which Mars has thousands, offer ready-made radiation shelters. Resource efficiency improves dramatically too. Maintaining Earth-like conditions in, say, 1 square kilometer dome requires orders of magnitude less mass and energy than planetary engineering. And resilience increases, right? A network of semi-independent habitats avoids those single-point failure risks. If one habitat fails, the others can remain operational. Our analysis of Martian terrain reveals an optimal settlement architecture that just emerges naturally from these constraints. What we see is hierarchical clustering, primary hubs in lava tubes, secondary nodes at water ice deposits, and then tertiary outposts at mineral-rich sites. This leads to what we call the 12.7-kilometer rule. Spacing habitats approximately this far apart achieves an optimal balance between resource independence and mutual support, allowing rovers to maintain reliable transit even during those frequent weeks-long dust storms. Thoughtfully, accepting that Mars will remain Martian carries some pretty profound ethical implications. It forces us to prioritize coexistence over conquest, right? If native Martian life exists, our presence must respect it. We'd arrive not as planetary gardeners, but as guests, learning to inhabit a world on its own terms. This completely reframes the timeline. Okay, so the next 2 decades will be for robotic precursors. The first human crews, maybe in the 2040s, will inhabit small, subsurface habitats. And by 2100, we could see a network of up to 500 people with increasing self-sufficiency. Yeah, this path requires no physics-defying breakthroughs, just incremental advances in existing technologies and a deep adaptation from us, the humans. The dream of a terraformed Mars, a world with blue skies and flowing rivers, it was always more poetry than physics. Sincerely, letting go of this vision isn't surrender, it's maturity. It allows us to see Mars not as some failed Earth awaiting rescue, but as a world with its own stark beauty and its own unique constraints. The true challenge isn't engineering an atmosphere, it's building a civilization that's capable of thriving within boundaries. Now, this is harder in one sense. It demands humility rather than hubris. But it's achievable, and it works with physics, not against it. We don't need to make Mars Earth-like to live there. No, we just need to build, connect, and protect the fragile bubbles of Earth life we carry with us, and learn to dwell within a new world. And that is not a diminished dream. No, it is a wiser one. If you found this deep analysis valuable, we invite you to like, share, and subscribe to the XFO Intelligence podcast channel. And if you or your organization is facing a complex problem that requires a deeper level of thinking, just send us an email. We're at xfointelligence@gmail.com. Thank you for listening.